Every Fiori Elements app you see, every list report, every object page, every analytical dashboard is powered by a CDS view underneath. Core Data Services views are the data modeling layer that sits between your database tables and the Fiori UI. Get them right, and your apps are fast, maintainable, and ready for SAP's clean core strategy. Get them wrong, and you end up with slow queries, duplicated logic, and a maintenance nightmare. Today, we are going to cover the architecture patterns, annotation layers, and performance strategies that separate production-quality CDS views from quick prototypes. If you are an ABAP developer building the data foundation for Fiori apps, this is your blueprint.
SAP recommends a two-layer CDS view architecture. The first layer is the interface view, prefixed with I_. Interface views sit directly on top of database tables and define the canonical data model. They contain field mappings, associations to other entities, and reusable business logic like calculated fields and currency conversions. They are reusable across multiple consumption scenarios. The second layer is the consumption view, prefixed with C_. Consumption views sit on top of interface views and are tailored for a specific Fiori app. They add UI annotations, search configurations, and field-level customizations that only make sense for one particular Fiori app. The separation matters because when SAP upgrades your system, only I views need to align with table changes. Your C views remain stable because they depend on the interface contract, not on raw tables.
Annotations are the bridge between your CDS data model and the FIOR Elements UI framework. Instead of writing JavaScript to create a list or a form, you annotate your CDS view. And three annotation families matter most. First, @UI annotations. These control the visual layout, which fields appear in the list report, which go on the object page header, and which serve as selection fields for the filter bar. Second, @search annotations. These configure full-text search behavior, which fields are searchable, whether fuzzy search is enabled, and the ranking weight of each field. Third, @object model annotations. These define the semantic meaning of your entity, which field is the key, which represents an amount, a quantity, or a status. Object model annotations also control draft handling and transactional behavior in RAP, the RESTful ABAP programming model. The power of annotations is that they keep UI logic in the data model layer, not scattered across JavaScript files. CDS views do not exist in isolation. They connect to each other through associations and compositions. An association is a navigational link between two entities. For example, a purchase order header has an association to its items, and each item has an association to a material master. The target data is only fetched when the UI navigates to it or when an OData expand is requested. A composition is stronger. It defines a parent-child ownership relationship. If you delete the parent, the children go with it. In Fiori Elements, compositions drive the object page layout. A purchase order's composition to its items creates the items table on the order's object page. A common mistake is using associations where compositions are needed. If your Fiori app has a header item structure with create, update, and delete operations on the items, you need a composition, not an association. Associations are for read-only navigation. Compositions are for transactional parent-child hierarchies.
Sometimes you need a field in your CDS view that cannot be computed at the database level. Maybe it requires a call to a remote system, a complex ABAP calculation, or runtime context, like the current user's authorization profile. This is where virtual elements come in. A virtual element is declared in the CDS view with the annotation @objectModel.virtualElement, and its value is calculated at runtime by an ABAP class that implements the virtual element interface. The Fiori app sees this field just like any other. The key trade-off? They execute in the ABAP layer, which means they cannot be used in where clauses, aggregations, or sorts at the database level. Use them sparingly, and only for fields that genuinely cannot be calculated in CDS expressions or HANA SQL.
A CDS view that returns correct data is only half the job. It also needs to return it quickly. The #1 performance principle for CDS on HANA is pushdown. Let the database do the work. Every calculation, filter, and aggregation that you write in CDS expressions executes inside the HANA engine, close to the data. The moment you introduce ABAP-level processing, like virtual elements or exits, you break pushdown. 3 optimization strategies. First, avoid nested views beyond 3 to 4 levels deep. Each nesting level adds complexity to the HANA execution plan. Use the HANA SQL Analyzer or the Eclipse CDS analysis tools to visualize execution plans. Second, use aggregation annotations strategically. The @analytics.data category annotation tells the runtime whether your view is a dimension. Getting this right enables HANA's native aggregation pushdown. Third, be selective about which fields you expose. Every field in a CDS view is a column that HANA must read. If a field is never used by any consumption scenario, remove it from the interface view.
Let us see how these pieces fit. Imagine you are building a Fiori Elements list report for purchase orders. At the bottom, you have transparent tables, EKKO for header, EKPO for items, MARA for materials. Layer 1, you create I_purchase order header and I_purchase order item as interface views. These define field aliases, associations to each other and to the material master, and calculated fields, like net value in local currency. Layer 2, you create C_purchase order report as a consumption view. It sits on the interface views and adds @UI line item annotations, search enablement, selection fields for the filter bar, and a composition to the items entity. You register this view as an OData service in the service definition and binding. No custom JavaScript. That is the power of CDS-driven Fiori. Here is my recommendation. If you are starting CDS development for Fiori, invest your time in the interview level. Get the field mappings, associations, and business logic right at the interview level. Then building consumption views for different Fiori apps becomes a matter of adding the right annotations. Think of it like building an API. The interviews are your contract. The C views are your clients. A well-designed interface layer supports dozens of Fiori apps without duplication.